Okay, good morning everyone. Today we're going to go on to section 8.3. We'll be looking at adding and subtracting rational expressions, and then tomorrow we'll look at simplifying complex fractions. Expect a test on Wednesday that will cover sections 8.1, 8.2, and 8.3. So again, our objective for today is adding and subtracting rational expressions. Well, adding and subtracting rational expressions, and again, to recall, what is a rational expression? It's the ratio of two polynomials. So I could have something like 2x plus 1 over x squared minus x minus 6. That is a rational expression. Adding and subtracting rational expressions is no different than adding and subtracting fractions. Okay, to recall, you can only add or subtract fractions if they have the same denominator. So here I have 1/2, and then I'm going to add 1/2. So one day you eat 1/2 of a pizza, and the next day you eat the other half, so you've eaten the whole pizza. So again, because the denominator is the same, I can just add the numerator. Okay, so 1 plus 1 is 2. So this will be 2 over 2. The denominator stays the same. Okay, so 1/2 plus 1/2 is equal to 2 halves, and 2 halves, well, that equals a whole. And then likewise, here, my denominator is the same. I'm going to subtract 2 fractions, 3/5 minus 7/5. So I can just subtract the numerator. So 3 minus 7 is -4. So I get -4/5. Again, to subtract or add fractions, you have to have the same denominator. Well, if the denominators are not the same, you have to find the least common multiple of all the factors in the denominator. So least common multiple. Let me review. If I have a number like 2, 3, and 5, they're all prime factors. The least common multiple will be the number that you could divide by each of those factors, 2, 3, and 5. So one way you can find the least common multiple, particularly if all the factors are prime, and they are in this case 2, 3, and 5, you would just multiply them. So 2 times 3 is 6 times 5 is 30. So the least common multiple would be 30. Again, the least common multiple is that number that you can divide by each of the prime factors, 2, 3, and 5. Okay, so if the denominators are not the same, you have to find the least common multiple of all the factors in the denominator. Then you multiply each fraction by the missing factors. So here I have 1/2, and I'm going to add 1/3. The denominators are not the same, so the least common multiple of 2 and 3, well, you can multiply 2 times 3 is 6, so the least common multiple will be 6. Okay, so what I will need to do then is I will multiply the first fraction, 1/2, by the factor that's not in the denominator for that fraction, but it is in my least common multiple. So I need to multiply the first fraction by 3. So I'm going to multiply the numerator and denominator by 3 because my least common multiple has to include the 2 and the 3. And then the factor that's not in my least common multiple for 1/3 is 2, so I need to multiply the second fraction by 2, both the numerator and denominator. So notice I have the least common multiple, or both factors, 3 and 2 in each denominator. So here, this will give me 3. So this will give me 3 times 1 is 3, and so that will be 3, 6. And then 1 times 2 is 2, and that will be 2, 6. My denominator is the same, so I can add now. 3, 6 plus 2, 6 is equal to 5, 6. Okay, so again, if the denominator is not the same, find the least common multiple of all the factors in the denominator, then multiply each fraction by the missing factors. The least common multiple in that example included the 2 and 3. The 1/2 was missing the 3 in the denominator, and the 1/3 was missing the 2. let's look at the next example. Here I have 9, 3, and 5. Well, 9 I can represent as 3 squared. 3 times 3 is 9. Okay, so my least common multiple here, though, has to include all the powers of the prime factors. So I have 9, which is 3 squared, and I also have 5. So 3 squared and 5 will comprise my least common multiple. Why did I not include 3, though? Well, because 3 is already in 3 squared. Okay, so the least common multiple will always include the prime factor with the largest exponent. So let me explain. If I have 4 and 8, for example, okay, so 4 would be 2 to the second, and then 8 will be 2 to the third. So my least common multiple would be 2 to the third. If I had 16 and 32, for example, so 16 I can write as 2 to the fourth, and 32 will be 2 to the fifth. So my least common multiple would be 2 to the fifth. Okay. So when I have 9 and 3, the least common multiple has to include the 9, or 3 squared, and 5. So my least common multiple then, 3 squared is 9, and 9 times 5 is 45. My least common multiple would be 45. Okay, so again, I have to multiply each fraction by the factor that is missing in my least common multiple. For 1/9, I'm missing the 5, so I need to multiply the first fraction by 5, because I need 3 squared and 5 in each denominator. 3 squared and 5. Now, in the second fraction, 1/3, I'm missing a 3. Okay, I need 3 squared. I need 2 3s, so I'm missing a 3 and I'm missing a 5. So I'm going to multiply this by 15. 3 times 5. And then in the third fraction, 1/5, I'm missing the 3 squared, or the 9. So I'll multiply that by 9 and that by 9. So now, when I multiply, 5 times 1 is 5, so this would be 5/45. Plus 1 times 15 is 15, 15/45. And then 1 times 9 is 9, so 9/45. My denominator is the same. So I can add 5 plus 15 plus 9 will be 29/45. Done. Okay, so my least common multiple was 45, or 3 squared and 5. I have to make sure I have both 3's and 1 5 in each denominator, and I did here. So 5 times 3 squared, 3 times 3 times 5, and then 5 times 3 squared. Okay, so working with rational expressions is no different when we add and subtract rational expressions than working with fractions. So let's take a look at some examples. So let's say here I have x minus 3 over x plus 4 plus x minus 2 over x plus 4. My denominator is the same, x plus 4, so I can just add what's in the numerator. X minus 3 plus x minus 2. Okay, I'll have combined like terms. I'll get 2x minus 5 over x plus 4. All done. Can't simplify anything. Again, my denominator was the same. I can just add. Subtracting is no different other than the fact that we have to remember to distribute the negative. So here I have x squared plus 1 in the denominator and x squared plus 1. So I can just subtract what's in the numerator. Okay, I need to remember though, put parentheses around the 6x plus 1 because I'm subtracting. So I need to make sure I distribute the negative to the 6x and 1. So negative times 6x will be negative 6x, and negative times a positive 1 will be negative 1. And then I can combine my like terms. 3x minus 6x. 3x minus 6x will give me negative 3x. And then negative 4 minus 1 will give me negative 5. Again, the denominator was the same, so I can just subtract. but remember to distribute the negative. Now, to add and subtract rational expressions with unlike denominators, you first have to find the least common denominator, or LCD. The LCD is the least common multiple of all the polynomials in the denominators. To find the least common multiple of polynomials, you must factor each polynomial completely. For example, they give us x cubed and then plus 6x squared plus 9x. I need to factor that completely, so I can first factor out an x. That leaves me with x squared plus 6x plus 9, of which I can factor x plus 3 times x plus 3. Okay, if x was equal to 2, so let's just say if x was equal to 2, what would I have? I would have 2 times 5 times 5. So my least common multiple would be 2 times 5 times 5, or 5 squared. Okay, my least common multiple, again, keep in mind, as I said before, the least common multiple has to include all of the prime factors. So like when I did this one here, 9 and 3, well, I have 2 prime factors for 9, 3, and 3. So I have to include 3 squared, and then the 5. So going back down here, my least common multiple will be 2 times 5 squared. Well, here now, my least common multiple is going to be x times x plus 3 squared. Okay, so that would be my least common multiple. I have to have both x plus 3's. List the different factors. If the polynomials have common factors, use the highest power of each common factor. Okay, and so what's meant by that, for example, if I had x plus 2 as one factor, and then I had x plus 3 times x plus 2 squared, my least common multiple would have to use the highest power of each common factor. My common factor of x plus 2, I'd have to use 2 of them. So my least common multiple would have the x plus 2 squared, that's the highest power, and then the x plus 3. So that would be my least common multiple. So let's take a look at some examples. Find the least common multiple for each pair. So I have 4x squared y cubed. Okay, I could write that 4 as 2 squared times x squared times y to the third, and then 6 times x to the fourth, y to the fifth. I can write 6 as 2 times 3, and then x to the fourth, and then times y to the fifth. So my least common multiple, again, has to have the highest power of each common factor. So that means I need the 2 squared. I also need the 3, because I'm missing, so there's a 3. I need the 3 there, so times 3. And then I need the x to the fourth, because the highest power is 4, so times x to the fourth. And then I need the y to the fifth, because 5 is higher than 3, so times y to the fifth. So my least common multiple would be 2 squared times 3, or 12x to the fourth, y to the fifth. Okay, least common multiple. Let's look at example B, x squared minus 2x minus 3, and x squared minus x minus 6. So when I factor x squared minus 2x minus 3, I get x minus 3 times x plus 1. And then when you factor x squared minus x minus 6, you get x minus 3 times x plus 2. Okay, so my least common multiple has to have the highest, has to have each factor with the highest power. I have x minus 1 and x minus 1, so my least common multiple, or x minus 3 and x minus 3. So x minus 3 and x minus 3, and the powers are the same, so 1 and 1, so I need the x minus 3. And then I need the x plus 1. have to include all the factors, and then the x plus 2. So the least common multiple would be x minus 3 times x plus 1 times x plus 2. What happened if I had x minus 3 squared, and then x plus 1, and then x minus 3, and then x plus 2? In that case, my least common multiple would have been the x minus 3 squared times the x plus 1 times the x plus 2. All right, for that case there. So let's continue on here. That was just an example. All right. Again, we have 4x cubed y to the 7th and 3x to the 5th y to the 4th. So again, 4 I can write as 2 squared. And then I have x to the 3rd and y to the 7th. And then I have 3 times x to the 5th y to the 4th. So my least common multiple, it has to have the 2 squared times, I also need the 3. Oops, let me make that 2 squared. I also need the 3. And then the largest exponent I have for x is x to the 5th. So times x to the 5th. And then the largest exponent I have for y is y to the 7th. So my least common multiple then would be 2 squared is 4 times 3 is 12, x to the 5th, y to the 7th. So let's go over some examples here. Here I have 2x minus 3 and 2x squared minus x. So again, the name of the game is factoring, and we need to find the least common, multiple. So 2x minus 3 is one factor, and then 2x squared minus x, I have to factor that, so I factor out an x, and that leaves me with 2x minus 1. Okay, so my least common multiple has to include all the factors. Okay, so I need the x, the 2x minus 1, and then the 2x minus 3. So my least common multiple will have the x, the 2x minus 1, and the 2x minus 3. That would be my least common multiple. Let's take a look at x squared minus 4x plus 4. So when I factor x squared minus 4x plus 4, I'll get x minus 2 times x minus 2, or x minus 2 squared. And then I have x squared plus x minus 6, and when I factor that, I'll get x plus 3 times x minus 2. Okay, the largest power I have for x minus 2 is x minus 2 squared, so my LCM has to include the x minus 2 squared and then the x plus 3. Okay, so you're probably wondering, why don't I have the x minus 2 included? It's included in the x minus 2 squared. Again, you always include that factor with the highest exponent, x minus 2 squared, x plus 3. Let's look at the next example here. Here, I have 4x squared. 4x squared. So I can write 4 as 2 squared, so 2 squared times x squared. And then I have 2x squared plus 4x I need to factor. So I'm going to factor out an x, and that leaves me with x plus 2. Okay, so I have factors of 2 squared versus 2. Again, 2 squared is larger, the exponent for 2 squared is larger than the exponent for 2 to the first. So my LCM has to include the 2 squared, so I need that 2 squared. And then I have the x squared and the x. Oops. I have the x squared and the x. So my LCM has to include the x squared. And then the LCM has to include the x squared. And then finally I have the x plus 2 that's included. So there, my least common multiple will include the 2 squared, the x squared, and the x plus 2. And then finally, I have 3x plus 6 times 4x minus 12. I'll factor out the 3. That will be 3 times x plus 2. 3 is a factor, x plus 2 is a factor. I'll factor out of 4, I'll get x minus 3. So now I have the factors 3, x plus 2, 4, and x minus 3. My LCM has to include 3, and it has to include the 4. So 3 times 4. And then it has to include the x plus 2 and the x minus 3. So my LCM includes all those factors. The least common multiple. All right. And with that, then we can actually go on to adding and subtracting rational expressions. So here, let's say here I have x minus 3 over x squared plus 3x minus 4, and I'm going to add to that 2x over x plus 4. Again, you need to factor your denominator to find the least common multiple. When I factor x squared plus 3x minus 4, I get x plus 4 times x minus 1. Now notice I have x plus 4 as a factor in that denominator and x plus 4 as a factor in that denominator. My least common multiple, though, has to include the x plus 4, and it has to include the x minus 1. Okay, I need all those factors, x plus 4 and x minus 1, which means I need to multiply the second fraction by x minus 1 because that's the factor I'm missing in my denominator for the second fraction. I only have x plus 4. So I need to multiply the second fraction by the factor that I'm missing, which is x minus 1. So here, when I multiply, okay, so here they're multiplying. So I get 2x times x is going to be 2x squared. And then 2x times negative 1, that would be negative 2x. So I have 2x squared minus 2x. And then I can combine my like terms. So I just have just the 2x squared. And then let's see here, I have an x minus x, which will give me a negative x. And then I have a negative 3. Okay, so when I subtract or add x minus 3 plus 2x times x minus 1, you get 2x squared minus x minus 3. And you should always try and factor if you can to see if you can reduce your fraction. In this case here, I can't factor 2x squared minus x minus 3. That would give me a factor that's in my denominator, x plus 4 times x minus 1. Okay, if I tried to factor 2x squared minus x minus 3, let's see here, 2x and x. And then this would be minus 3 plus 1. All right, so that would give me, so that would give me 2x squared minus x minus 3. But notice I would not be able to cancel out either one of those factors with the factor that's in the denominator. Okay, so we just leave it that way. Yeah, so this would actually have factored 2x minus 3 times x plus 1. But I would not have been able to cancel out one of those factors with the factor in the denominator. So we can leave it that way. All right, let's continue on here. Here I have x over x plus 2 plus negative 8 over x squared minus 4. So x squared minus 4, if I factor that, that's a difference of squares. That's x minus 2 times x plus 2. So here I have x plus 2 times x minus 2 in that denominator. and then I have an x plus 2 in that denominator. So out of the first fraction, I'm missing the x minus 2, so I have to multiply the first fraction by x minus 2. I need both factors, x plus 2 and x minus 2, in my denominator. When I multiply the first fraction by x times x minus 2, what will I get? I'll get x squared minus 2x. And then plus negative 8 or minus 8. So when I combine everything, I'll get x squared minus 2x minus 8 over x plus 2 times x minus 2. Now here, okay, thinking of looking ahead, I can factor x squared minus 2x minus 8, and that's x plus 2 times x minus 4. Well, this factors x plus 2 times x minus 4. Okay, and now I notice I can cancel out that x plus 2 with the x plus 2 in the denominator. So that gives me then x minus 4 over x minus 2 simplified. Okay, so you should always try and factor. So when you get to this point here, you should try and factor the numerator to see if you can cancel out a factor in the denominator. And I was able to with that one. With the other one, with this one here, I couldn't. When I factored 2x squared minus x minus 3, I got 2x minus 3 times x plus 1. But I was not able to cancel out a factor in the denominator. I had x plus 4 and x minus 1. Couldn't do it. Okay, and then we'll just look at a couple more here. So here I have the 2x minus 2 as one factor, and then 3x minus 3 as another factor. I need to factor 2x minus 2. When I factor 2x minus 2, I'll get 2 times x minus 1. And then when I factor 3x minus 3, I'll get 3 times x minus 1. So my LCM, it has to include the 2, the 3, and the x minus 1. Those are the 3 different factors. So I need to multiply the first fraction by the factor that I'm missing the 3. And I need to multiply the second fraction by the factor that I'm missing the 2. So 3 times 3x is 9x. And then when I distribute the 2, 3x times 2 is 6x, and then negative 2 times 2 is negative 4. And I can combine my like terms. I get 15x minus 4 over 6 times x minus 1. And nothing I could reduce there. Nothing I could reduce. All right, and the last example I wanted to go over is maybe, let's say here, if I had something like this. Here's an example. If I have 5x over x squared plus 4x plus 4, and then minus 2, I'll just make up 1, minus 2 over x squared plus 5x plus 6. Okay, so again, we want to subtract these fractions here. So step number one, we have to find the least common multiple. So when I factor x squared plus 4x plus 4, I'll get x plus 2 times x plus 2, or x plus 2 squared. X plus 2 times x plus 2, or x plus 2 squared. Now when I factor the other one, I'll get x plus 2 times x plus 3. Okay. So, but what I want you to notice here is that I have an x plus 2 in both denominators, but here, the LCM, it has to include the one with the highest exponent. So my LCM, my least common multiple, it has to include the x plus 2 squared, and then it has to include the other factor, x plus 3. So my LCM has to include the x plus 2 squared and then the x plus 3. Okay, so if I were to do the example here, so what factor am I missing out of the first fraction? Well, I'm missing the x plus 3. I'm missing the x plus 3, so I'm going to multiply the first fraction by x plus 3. And so I need to multiply, so this is going to be 5x over x squared plus 4x plus 4. And then I will subtract, let me see here. So what am I missing? So what am I missing in the other fraction? Well, let's see here. I'm missing one of the x plus 2's because I only have one of them. I only have one of the x plus 2's. I need two of the x plus 2's, so I need to multiply this one by x plus 2. Okay. And then now, so here I would have x plus 3 times 5x, and I'm just going to ignore the denominator, minus 2 times x plus 2, and then the denominator. I'll just leave that alone just for a second here. Okay, so that's what I have. And then if I, so this would give me, what's that, 5x squared plus 15x minus 2x minus 4, and so that would be 5x squared plus 13x minus 4. That would be my numerator. Okay, that would be my numerator, so my final answer would be 5x squared plus 13x minus 4 over my denominator, which would be, so again, my LCM would include the x plus 2 squared and the x plus 3. So there. And I can multiply that through, but it's not necessary. We'll leave it like that. Unless you could factor that. And I don't believe you can factor the numerator. No, you would not be able to factor that. So that would be the final answer. But I didn't want to make the point that I have the x plus 2 squared, and it has an exponent of 2, and I have the x plus 2 there, but my LCM has to include the x plus 2 squared, and then the x plus 3. That's really no different than if I had 1/2 plus 1/4. So, right, 1 over 2 plus 1 over 2 squared. I'd need to multiply this fraction by 2. I need the 2 squared in each denominator, and so that would be, what's that, 2 over 4 plus 1 over 4 equals 3/4. Just like fractions.